Hi everyone. So today we're going to start talking about forensic anthropology. So as we talk about death investigations and looking at what we can get from a death investigation or a dead body, we see that the importance of anthropology or looking at human remains, the influence that it can play in our forensic investigation. So forensic anthropology is the examination of human remains. Typically, we're talking about bones to determine the identity of an unidentified body. We like to try to figure out height, race, sex, as well as physical health using these skeletal remains. We can, to varying degrees, determine these things. Um, uh, so when we talk about bones, it's important to understand just the basic anatomy of bone tissue. And with bone tissue, there are a number of bone cells or osseous type of cells that we talk about. Osteoblasts are going to be the cells that are going to create new bone tissue and help for ossification or creating that hardened material. And you have osteocytes, which are the mature or the adult bone cells that make up the basic framework of the bone. So you have your osteocytes, which are really our bone cells, but then you also have your osteoblasts, which are going to make new bone tissue, and you have your osteoclasts, which are going to get rid of old bone tissue and helps us to reshape our bones as we put more stress on our bones and we want to make our bones more adapted to what we're doing with our bones. So depending on how you use your bones, what type of athlete you are, it's going to really change how our bones are and where they are strong. So depending on what you're doing, it's going to reshape your bones. And these osteoclasts and osteoblasts are constantly working to make sure that there's new bone and that we're getting rid of old bone that we don't want anymore. So when we look at skeletal remains, there's one thing that we're able to determine, and we're going to be able to see the difference between sexes. So the biggest difference between sexes are going to be found in the skull and the pelvis. So typically we're looking at a number of things. Upper brow ridge is a good indicator. Occipital protuberance, frontal bone, the ramus of the mandible, the subpubic angle, as well as the shape of the pelvic cavity are going to indicate if this individual was biologically male or biologically female. So we look at the upper brow ridge. Now, the upper brow ridge in females is going to be thin and small. In males, we're going to see that it is thick and large. The occipital protuberance, if you feel the back of your head, in males, it's going to be present. This bump is going to be present in the back of the head. And in females, it is going to be absent. Now, the frontal bone, we see that in females, it's much higher and more rounded, where in males it's going to be low and more sloping. So you have rounded in females and sloping in males. And then the ramus of the mandible, you're going to see that it's straight in males and it's more slanting in females. So when you look at these skulls now, it's not something that's necessarily going to jump immediately out at you, and you can see to varying degrees maybe some more male traits in a female skull and more female traits in a male skull. It's not like they are so different that it's impossible to see kind of an in between or an intermediate, but typically we're going to be able to, or a forensic anthropologist is going to really be able to pinpoint if it's a male skull or female skull, male pelvis, female pelvis. We also see that typically the mandible is going to be larger and more robust in males, and in females it's going to be smaller and less robust. We also see that the general appearance is going to be rougher in males and a lot smoother in females. So when we talk about this upper brow ridge, okay, we see that in males there's more of a ridge to it. In females, it is more dainty. There's not really that ridge. Sometimes you'll hear it called a supraorbital, all right, above the eyes ridge, but that's the same as saying upper brow ridge, just a more anatomically correct term for it. Also, occipital protuberance, you see in males, you have this bump. Okay, it looks drastic here. When it's covered in skin, it might not be as drastic, but in females, it's not present. And then we look at the frontal bone in males, you're going to see it has more of a sloping look to it, where in females it's going to be more of a rounded look to it. And that's we say it's the forehead, but ultimately it's this part of the skull that we refer to as the frontal bone. So the skull is made up of a number of bones that come together at these points called sutures, and these different bones that come together are going to be different between males and females, and also going to be different based on the age of an individual. So while we're looking at male versus female, we can also look at the age. Now, when we look at the pelvis of an individual, we see that the subpubic angle, so there's an angle at the bottom of the pelvis, it's going to be greater than 90 degrees in females. It's going to be less than 90 degrees in males. When we look at the shape of the pelvic cavity, we see that males have this heart-shaped pelvic cavity, which is not really conducive to childbirth, where female pelvic cavity is going to be more of an oval shape, which allows for the passage of a baby through that canal. Also, the angle of the femur, so when we look at those thigh bones, we see that in females, it's more of an inward angle, and males have more of a straight angle to their femur. Here we see we're looking at the pubic angle here. Okay, so in males, it is a lesser angle, and in females, it is a greater, more obtuse angle to it. And we also see that this right here, okay, this is a cartilaginous region right here that is called the pubic symphysis. It's where the two sides of the pelvis are going to be mended together by this cartilage. And what we see is that we can also look at this to try to determine if this female gave birth before. So in female, once we determine that it is a female pelvis, we can actually look at this pubic symphysis and see that if it's been stretched or torn at all, because that is going to happen during childbirth, and that gives us a better indication of who this individual really was when they were alive. This is the point of doing this. All right, we want to try to figure out who this individual is, and all of this stuff that we're doing, maybe we can't exactly pinpoint the exact age of the individual, the exact race of the individual, the exact socioeconomic status of this individual. We might not be able to pinpoint all these things exactly, but we can at least make note of it to try to use it as evidence to figure out who was this, or possibly who was this individual. We also see that this inlet is different between the male and the female. The shape is also different, where you see that in the female, it's a lot wider to it. Okay, again, more conducive for childbirth. When we look at the angle of the femur in the female, we have more of an angle to it. In the male, it's more of a straight femur bone to it. Now, we can talk about trying to determine race as well. Race is something that's difficult to determine because of the social aspect to it, but we do like to try to ultimately figure out the ancestry of the individual, and we cannot definitively determine the exact ancestry, and we definitely can't determine the exact race of an individual, but we do like to try to pinpoint what's the most probable ancestry, and going by what's the most probable ancestry somewhat make maybe a correlation to what the individual's race was. So it's difficult to define and categorize race. It comes under scrutiny, but forensic anthropologists will try to determine a likely but never definitive ancestry to an individual. So the information is noted in hopes that it could potentially help determine who the remains belong to. But again, it is something that is never definitive. It's more of something that we're going to make note of and try to make a correlation to. So as time goes on, it becomes increasingly more difficult to establish the race of a skeleton, also because of the blending of cultures and races. And genetics continue to be crossed as time goes on. But once upon a time, we had these different groups of people, and that's why you'll see that when we talk about ancestry, we'll put individuals into one of three groups. Either they'll be European, which was once referred to as the Caucasoid group of individuals. You have African people, sometimes you'll hear it referred to as Negroid, and then Asian, which is referred to as Mongoloid. So while we like to use these terms now more, European, African, and Asian, you will sometimes hear people refer to them as Caucasoid, Negroid, and Mongoloid. But based on these, we can look at the skeletal remains. And again, it's not the easiest thing to see, and there are overlaps. You can have Europeans that have more African looking or African like traits, just like you can have Asians with more European like traits. So it's not a perfect science, but it is something that we're taking note of. So in Europeans, we see that the eyes, all right, are square shaped. So when we look at the skeleton, the eyes are square shaped, or they have square orbits. In Africans, we see rectangular orbits in the African ancestry, and in Asian ancestry or Asians, you see circular orbits. Also, the nasal spine is going to be large in both Europeans and Asians, and it's going to be small in African ancestry. The maxilla, or the upper jawbone, lines up with the mandible, and then you're going to see that in African ancestry, there's going to be the maxilla is going to protrude past the mandible, and in Asian ancestry, there's going to be a variable between this prognathism. And then fingers are going to fit under the curvature of the femur. So when we look at the thigh bone, all right, there's this gap or this curvature of the femur. And then in the African ancestry, we do not see that curvature. And in Asian ancestry, there is that curvature. So there's small differences when we look at this ancestry. But again, you see that different people are going to have possibly, if they're from one ancestry, they might still have traits that are similar to another ancestry. So not a perfect science, but something that we can take note of and try to really make a guesstimation of what was the ancestry of this individual, and maybe what was their race while they were alive. So here you see, all right, not something that's easy to really tell. All right, I wouldn't be able to really look at a skull and immediately pick up on it, but a forensic anthropologist is going to be good at determining, hey, this looks rather square shaped, this is more of a circular shape, and this is more of a rectangular shape to it. Now, age is something that is relatively easy to kind of come up with a range for in younger individuals. As an individual gets older, it gets a lot harder. You're going to see that we look at certain fusing of bones, and when we look at the fusing of bones, when you are growing, when you are a child into becoming an adolescent, there's a lot of different bones that are fusing, so we can use all these different bones to really pinpoint, is this individual 4 years old or 8 years old? Are they 8 years old or 12 years old? We can really try to pinpoint a small range of how old this individual is. So if we look at the humerus and we see that upper arm bone is going to be fused, that happens between 4 and 6 years old. If we look at the pubis and the ischium, those pelvic bones, they're almost completely united between 7 and 8. So if we see that they're completely united, we know that they're older than 7 or 8 years old. Okay, if they're not, but they do have that humerus bone, the head of the humerus bone is going to be fused, then we know that they're going to be between probably 6 and 7 years old. We're using this to try to figure out how old is this individual. We see between 16 and 18, the head of the femur is fused to the shaft of the femur. So these are all things that we can use. We see that if this pubis and ischium are united, but the head of the femur has not been fused yet, then we know they're between 8 and 16. So we're coming up with these rather small ranges of the age an individual could be. Now, when we look at the head of the humerus is fused to the shaft of the humerus between 18 and 20. And then we start to look at the skull, because the rest of the body by 20 is all the bones are really fused. You're done growing, but the skull continues to turn your cartilaginous pieces into hardened bone. So we see that the lambdoidal suture is going to close between 21 and 30. Now you see that before we were trying to pinpoint, is this person 4 or 8? Now we're trying to pinpoint, is this person younger than 21 or older than 30? Now the ranges get a little bit bigger. Between 25 and 30, you see all segments of the sacrum are going to be united. All right, so when we look towards that tailbone, we're going to see that the segments are united. At around 32, you see the sagittal suture in the skull is going to be closed, and then it's not until 50 years old that you see that the coronal suture is going to be closed. So we might not be able to say that the person is exactly 36 years old, but we could say they're probably older than 32, younger than 50. If they're all closed, then we know that this individual is older than 50. Do I know if they're 55, 60, 65, 70, 70? I don't know that, but I do know they're older than 50. So we can't really pinpoint, hey, this individual is this exact age, but we can tell, hey, this person is older than 50, younger than 50. This person is younger than 32, older than 32, and that can kind of give you an idea of the general age of this person, right? Were they of working age, or did they, did they probably have children, or were they of the age to have children, or were they of the age to have grandchildren? This kind of helps you paint a picture of who this individual might have been based on their age. So when we look at bones, typically when we're not looking at them from remains, if you just were to x-ray an individual, you could come up with an idea of their age by looking at these epiphyseal plates, or the where the fusing is occurring. So an individual that is 9 years old, you're going to have this cartilaginous region here. So the bones haven't fused yet. Their individual is still able to grow. All right. When we look at these long bones, we see that they grow in these cartilaginous regions. Once they're fused, that bone has stopped growing. So we see that in this 9-year-old individual, it hasn't fused yet. So we're able to say, hey, this person's under 13 years old. Once they hit 13, we take another x-ray and we see, hey, wait a second, this has fused now. This is all bone. There's no more cartilage there. And that's what we're looking at when we look at skeletal remains, is are those bones fused together, or is there still that cartilaginous region there, which is going to indicate that they are younger than the age that we see that they're fused. So we see in infants, okay, these areas are all cartilaginous. That's why you see that babies are often have these soft heads, and you can they come out all in weird shapes, and eventually they straighten out. Okay, but that's to help them to make their way through the birth canal, and then once they're through, this starts to harden. But it takes a full 50 years for them to completely harden. So we have this suture here. Okay, this suture here is cartilaginous, and it slowly is going to start to harden up until 32. All right, so once you're around 32 years old, that has completely closed. These bones have fused together. You see that between 21 and 31, this is closing up or fusing together. And it's not until 50 that we see this one close together. So this is what it looks like as an infant. Everything is very large. There's a lot of cartilage, but over time, it's slowly creeping together. The cartilage is getting smaller and smaller. The bone is getting larger and larger, and it is coming to meet together. So as an adult, you see this is a skull of someone that's over 50 years old. It's all been fused. You have your lambdoid or lambdoidal suture fused. You have your sagittal suture fused, and then by 50, you have your coronal suture fused. So all of these things are going to be used to determine the age of an individual. Now, believe it or not, we can actually also come up with an idea of the socioeconomic status of an individual by looking at their dental remains. So typically, going to the dentist is something that more affluent people do more often, and really good dental work is very expensive, and you're going to see that that's something that's going to indicate someone had a decent amount of money. If they had a lot of cavities that were untreated, unfilled, that's going to indicate low socioeconomic status, and someone that possibly struggled with finances. So by looking at those dental remains, you can come up with an idea of, were they low socioeconomic status, maybe middle, and maybe upper socioeconomic status. And lastly, we can try to determine height based on these calculations that forensic anthropologists have come up with, and by looking at certain bones. So we can look at the one of the forearm bones, and we take the length in centimeters and multiply it by this number, and then add 58 to it. That tells us the approximate height of that individual if we're looking at a female. There's another calculation for a male, and then we can also do it based on the humerus, based on the tibia. So different bones have different calculations that they come up with. You'll also see other ones where they have different calculations based on the assumed ancestry, or what they think the ancestry of that individual was. So there's different calculations, but we can use all these calculations to come up with an idea of how tall this individual was. Or do we know for a fact that this individual was 5'10"? No, but we can come up with an idea that, they were probably around 5'10", maybe they were 5'8", maybe they were 6 foot, but they definitely weren't 4'11", and they definitely weren't 6'6". So keep these things in mind as we move forward and we're talking about death investigations.